Part 1. The Beginning of Dreams. This is DreamJourney-Stories, providing mind-blowing stories and mildly accurate reporting. So close your eyes and let yourself drift back through time, back to a world where the sky was not yet a destination, but simply something to wonder at. Long before rockets and satellites, long before the word astronaut even existed, humanity looked up at the stars and dreamed. Our story begins not with a launch, but with a question that echoed through centuries. What if we could touch the heavens? For most of human history, this seemed impossible, the realm of gods and myths. But everything changed on October 4th, 1957, when a small metal sphere changed the course of human destiny. This sphere, called Sputnik 1, was only about the size of a beach ball, just 58 centimeters in diameter. Yet it became the first human-made object to orbit our planet. As it circled Earth every 96 minutes, its radio beeps echoing down to listening stations below. The space age was born. The success of Sputnik sent ripples across the world, particularly in the United States, where it sparked what became known as the space race. Just 1 month later, on November 3rd, 1957, the Soviet Union achieved another first. They sent a living creature into orbit, a small dog named Laika, who became the first animal to orbit Earth aboard Sputnik 2. Though her journey was one way, Laika proved that living beings could survive the launch into space and the weightlessness beyond, paving the way for human spaceflight that would follow. The Americans, determined not to be left behind, created NASA, the National Aeronautics and Space Administration, in 1958. This new agency would become the vessel for American dreams of space, bringing together the brightest minds in science and engineering. But the Soviets continued to lead the way in these early years, achieving milestone after milestone. Then came April 12, 1961, a date that would forever mark humanity's boldest step. A young Soviet pilot named Yuri Gagarin climbed aboard Vostok 1 and became the first human being to journey into space and orbit the Earth. His flight lasted just 108 minutes, a brief but profound journey that took him once around our blue planet. As he looked down at Earth from his small capsule, Gagarin reportedly said, "I see Earth. It is so beautiful." In that moment, suspended between heaven and earth, he saw what no human had ever seen. Our world is a small, fragile sphere floating in the cosmic darkness. The flight of Vostok 1 fundamentally changed our perspective. Gagarin didn't just orbit Earth. He showed us that the boundary between our world and space was not as insurmountable as we believed. When he returned safely, landing in a field in the Soviet Union, he had proven that human beings could survive in space, could orbit our planet, and could return home. The dream was becoming real. America responded with determination. Less than a month after Gagarin's flight, on May 5, 1961, astronaut Alan Shepard became the first American in space aboard Freedom 7. Though his flight was suborbital, a 15-minute arc that took him just beyond Earth's atmosphere before returning. It was another crucial step. Shepard reached an altitude of 187 kilometers and experienced about 5 minutes of weightlessness, proving that Americans too could venture beyond our atmosphere. But the true race was just beginning. On May 25, 1961, President John F. Kennedy stood before Congress and made a declaration that seemed almost impossible. America would land a man on the moon and return him safely to Earth before the decade was out. This wasn't just a prediction. It was a promise, a commitment of national will and resources to achieving something that many thought belonged only in science fiction. The path to the moon would require small steps, each one building on the last. The Mercury program gave way to Gemini, where astronauts learned to maneuver spacecraft in orbit, to dock with other vehicles, and to survive for longer periods in space. On June 16, 1963, another barrier fell when Soviet cosmonaut Valentina Tereshkova became the first woman in space aboard Vostok 6, orbiting Earth 48 times over nearly 3 days. She remains, to this day, the only woman that completed a solo space mission, a reminder how rare such opportunities were in those early years. As you drift toward sleep, imagine the courage of these early explorers. They climbed aboard rockets knowing that every flight was an experiment, that every journey beyond Earth's atmosphere was stepping into the unknown. They were test pilots and pioneers, dreamers and scientists, and they carried with them the hopes of millions who watched from below, wondering what discoveries awaited us in the darkness above. Part 2, Walking Among the Stars. Let your breathing slow as we continue our journey through the cosmos, through a time when each new mission pushed the boundaries of what humans could achieve beyond our atmosphere. In those early days of space exploration, astronauts and cosmonauts were confined to their capsules, floating inside small metal shells as they orbited Earth. But on March 18, 1965, Soviet cosmonaut Alexei Leonov changed everything. Tethered to his Voskhod 2 spacecraft by a 5-meter cord, he opened a hatch and floated out into the void, becoming the first human to walk in space. For 12 minutes and 9 seconds, Leonov drifted outside his craft, with nothing between him and the infinite darkness but his spacesuit. The experience nearly cost him his life. His suit ballooned in the vacuum of space, making it nearly impossible to squeeze back through the airlock. But he succeeded, proving that humans could work outside their spacecraft, a capability that would become essential for all future missions. The Americans followed quickly. Just months later, on June 3, 1965, astronaut Ed White stepped out of Gemini 4 and became the first American to walk in space, remaining outside for 23 minutes. White was so enchanted by the experience that he later described it as the saddest moment of his life when he had to return inside. These spacewalks, or EVAs, extravehicular activities, show that astronauts could repair spacecraft, build structures, and work in a weightless environment beyond their vessels. As the 1960s progressed, missions grew longer and more complex. The Gemini program flew 10 crewed missions between 1965 and 1966, each one testing vital skills needed for the journey to the moon. Astronauts practiced rendezvous and docking maneuvers, bringing 2 spacecraft together in orbit with precision. They learned to control their spacecraft's orientation, to change orbits, to navigate by the stars. Each mission was a rehearsal, a careful preparation for the grand performance that would come. By 1968, the pieces were falling into place. The mighty Saturn V rocket, the largest and most powerful rocket ever successfully flown, stood ready. This towering giant stood 110.6 meters tall, taller than the Statue of Liberty, and weighed 2.8 million kilograms when fully fueled. When it launched, its 5 first-stage engines generated 7.6 million pounds of thrust, enough to shake the ground for miles around and create a sound so powerful it could be felt in your chest even from a safe distance. The first crewed test of Saturn V came with Apollo 8 in December 1968, and it was nothing short of audacious. Rather than simply testing the rocket in Earth orbit, NASA decided to send 3 astronauts, Frank Borman, James Lovell, and William Anders, all the way to the moon. This was humanity's first journey to another world, the first time humans would leave Earth's orbit and venture into deep space. On December 24, 1968, Apollo 8 entered lunar orbit, and the 3 astronauts became the first humans to see the far side of the moon with their own eyes, that mysterious half of our natural satellite that always faces away from Earth. But perhaps the most profound moment of Apollo 8 came not from looking at the moon, but from looking back at Earth. As their spacecraft emerged from behind the moon, the astronauts witnessed something no human had ever seen: our entire planet rising above the lunar horizon. William Anders captured this moment in a photograph that would become known as Earthrise, an image showing our blue and white world floating in the black void of space, partially obscured by the gray, lifeless lunar surface. This single photograph would help spark the environmental movement, showing humanity how fragile and precious our home truly was. The crew of Apollo 8 spent 20 hours orbiting the moon, circling it 10 times before firing their engines to return home. On Christmas Eve, as they looked down at the moon passing beneath them, they read passages from the book of Genesis to the largest television audience in history at that time. In that moment, humanity had reached another world, and the moon was no longer just a distant light in the sky. It was a place we had visited, a destination we had reached. The stage was now set for the ultimate achievement. Apollo 9 tested the lunar module in Earth orbit in March 1969, proving that this strange, spider-like craft could separate from the command module and return safely. Then Apollo 10 took the lunar module to the moon itself in May 1969, descending to within 15.6 kilometers of the lunar surface. So close the astronauts could see the moon's craters and boulders in sharp detail. Before returning to the command module, it was a dress rehearsal, testing everything except the actual landing. And then came July 1969. Apollo 11 launched on July 16th, carrying 3 astronauts toward destiny: Neil Armstrong, Buzz Aldrin, and Michael Collins. For 4 days, they traveled to the void between worlds, Earth gradually shrinking behind them while the moon grew larger ahead. On July 20th, while Collins remained in lunar orbit aboard the command module Columbia, Armstrong and Aldrin climbed into the lunar module Eagle and began their descent to the moon's surface. The landing was fraught with tension. The onboard computer was being overwhelmed with data, triggering alarms. The designated landing site was strewn with boulders. With fuel running critically low, they had less than 30 seconds of fuel remaining. Armstrong took manual control and guided Eagle to a safe landing on a relatively smooth area of the Sea of Tranquility. At 2017 Universal Time Coordinated, the words crackled back to Earth. Houston, Tranquility Base here. The Eagle has landed. Humanity had touched the moon. Let these moments wash over you as you relax deeper. Think of those astronauts, floating in the silence of space, looking back at Earth from another world. Close your eyes and drift, knowing that human courage and ingenuity had bridged the impossible gulf between our world and the moon. Part 3. First Steps on Another World. Breathe deeply and let yourself float back to that July night in 1969, when 500 million people around the world sat transfixed before their television sets, waiting to witness something that had lived only in dreams and imagination. After landing on the moon, Armstrong and Aldrin didn't immediately step outside. They had work to do, checklists to complete, systems to verify, preparations to make. The plan called for them to sleep before venturing onto the lunar surface, but neither man could rest. How could they, when they sat in a fragile craft on the surface of another world, with the ancient lunar dust just beyond their walls? So they asked Mission Control for permission to skip the rest period and begin their moonwalk early. Permission was granted. 6.5 hours after landing, Neil Armstrong opened a hatch of the lunar module and began climbing down the 9-rung ladder attached to Eagle's leg. At the bottom, he paused on the footpad, describing what he saw to the millions listening below: a fine-grained surface, almost like powder, and a stark, beautiful desolation stretching to the horizon. Then, at 2:56 Universal Time Coordinated on July 21st, 1969, Neil Armstrong placed his left foot onto the lunar surface and spoke words that would echo through history. That's one small step for man, one giant leap for mankind. Humanity had walked on another world. 19 minutes later, Buzz Aldrin joined Armstrong on the surface, becoming the second human to walk on the moon. As he took in the otherworldly landscape, Aldrin described it with simple eloquence. Magnificent desolation, and it was a world of grays and blacks, of craters and boulders, lit by the harsh, unfiltered sunlight and the soft blue glow of Earth hanging in the black sky above them. The moon had no atmosphere to scatter the light. so the sky remained pitch black even in daylight, filled with stars that never twinkled. Together, Armstrong and Aldrin spent 2 hours and 31 minutes on the lunar surface during that first moonwalk. They planted the American flag, though it took effort in the dense lunar soil. They unveiled a plaque attached to Eagle's descent stage that will remain on the moon forever, bearing the words, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." They collected 21.5 kilograms of lunar rocks and soil samples, carefully chosen specimens that would help scientists understand the moon's composition and history. They set up scientific experiments, a seismometer to detect moonquakes, and a retroreflector that scientists on Earth could bounce laser beams off to measure the precise distance to the moon. When their work was complete, Armstrong and Aldrin climbed back up Eagle's ladder, sealed the hatch, and rested. Then came perhaps the most critical moment of the entire mission, the launch from the moon. They had one engine, one chance. If it failed, there would be no rescue, no second attempt. But the ascent stage fired perfectly, lifting them off the lunar surface and carrying them back toward Michael Collins, who had spent those historic hours orbiting above them in Columbia, alone, on the far side of the moon, sometimes completely cut off from radio contact with Earth or his crewmates. The docking was successful, and the 3 astronauts began their journey home, leaving the Eagle's descent stage behind on the Sea of Tranquility, where it remains to this day. They splashed down in the Pacific Ocean on July 24th, 1969, completing a mission that had lasted 8 days, 3 hours, and 18 minutes. They had traveled approximately 1.5 million kilometers to the moon and back, and had fulfilled Kennedy's promise with 5 months to spare. But Apollo 11 was just the beginning. NASA had more missions planned, each one designed to explore different regions of the moon and conduct more extensive scientific research. Apollo 12 landed in November 1969, just 4 months after Apollo 11, touching down in the ocean storms with remarkable precision, only 155 meters from the Surveyor 3 probe that had landed there 2 years earlier. Astronauts Pete Conrad and Allen Bean walked the Surveyor, retrieved parts from it, and brought them back to Earth to study how materials weathered in the lunar environment. Then came Apollo 13 in April 1970, a mission that became one of the most dramatic survival stories in space exploration history. 2 days into the mission, more than 300,000 kilometers from Earth, an oxygen tank in the service module exploded, crippling the spacecraft. The famous words, "Houston, we had a problem," crackled across the void. The 3 astronauts, Jim Lovell, Jack Swigert, and Fred Hayes, had to abandon the command module and use the lunar module as a lifeboat, even though it was designed to support only 2 people for 2 days, not 3 people for 4 days. Through ingenuity, teamwork, and sheer determination, mission control and the crew improvised solutions to problems no one had anticipated. They built air filters from spare parts to prevent carbon dioxide poisoning. They calculated precise engine burns using the Earth's horizon as a guide. Against tremendous odds, Apollo 13 swung around the moon and returned safely to Earth, turning what could have been a tragedy into a testament to human resourcefulness. After Apollo 13, NASA made the mission safer, and exploration continued. Apollo 14 landed in February 1971 with Alan Shepard, who had been the first American in space nearly a decade earlier, becoming the 5th person to walk on the moon. At 47 years old, Shepard was the oldest person to walk on the lunar surface, and in a moment of joy on that alien world, he brought out a makeshift 6-iron golf club and hit 2 golf balls across the lunar landscape. In the moon's weak gravity, just 1/6 of Earth's, and with no air resistance, those balls flew extraordinarily far. It was a reminder that even in humanity's greatest technical achievements, there was room for playfulness and wonder. Let yourself sink deeper into comfort now, imagining those footprints in the lunar dust. Still there after all these years, preserved in a world with no wind or rain to erase them. Feel yourself drifting like those astronauts drifted through space, peaceful and weightless, as our story continues to unfold. Part 4, Rovers, Science, and the Final Footsteps. As you relax even deeper, let's journey to the later Apollo missions, when exploration of the moon became more ambitious, more scientific, and more adventurous. By 1971, NASA had learned much from the earlier missions, and the final 3 Apollo flights, 15, 16, and 17, were equipped with something revolutionary: the lunar roving vehicle, affectionately called the moon buggy. This electric car, designed specifically for the lunar environment, allowed astronauts to travel much farther from their landing sites than had ever been possible before. On Apollo 15 in July 1971, astronauts David Scott and James Irwin became the first to drive on the moon, and the rover performed beautifully. The vehicle could carry twice its own weight, and during the mission, the astronauts drove at a total distance of 27.9 kilometers across the lunar surface, reaching speeds of up to 13 kilometers per hour as they bounced along in the low gravity. Apollo 15 also marked a shift toward more extensive scientific exploration. Scott and Irwin spent 18 hours and 30 minutes outside their lunar module across 3 separate moonwalks, far longer than any previous mission. They collected 77 kilograms of lunar samples, including one particularly precious find, a rock that scientists would later call the Genesis Rock, believed to be over 4 billion years old, nearly as old as the moon itself. This ancient stone, crystallized in the moon's early history, offered a window into the formation of our solar system. The Apollo missions also left behind scientific instruments that continued working long after the astronauts departed. Each mission set up packages of experiments called ALSEP, the Apollo Lunar Surface Experiments Package. These stations measured moonquakes, the solar wind, the moon's magnetic field, and the flow of heat from the lunar interior. Some of these experiments operated for years, transmitting data back to Earth until they were finally shut down in 1977, continuing to teach us about the moon long after human footprints had last marked its surface. Apollo 16 arrived in April 1972, landing in the Descartes Highlands, the first mission to explore the lunar mountains. Astronauts John Young and Charles Duke spent 20 hours and 14 minutes exploring the surface across 3 moonwalks, driving their rover 26.7 kilometers and collecting samples from what they initially thought might be volcanic rocks. The samples they brought back surprised scientists. They weren't volcanic at all, but rather created by ancient impacts, teaching us that even the lunar highlands were shaped more by collisions than by volcanic activity. Then came the final mission, Apollo 17, launched in December 1972. This mission carried geologist Harrison Schmitt, who became the first and only professional scientist to walk on the moon. All the other moonwalkers had been military test pilots. Schmidt's presence brought an expert scientific eye to lunar exploration, and his enthusiasm was infectious. When he and Commander Gene Cernan discovered orange soil near Shorty Crater, Schmidt's excited voice echoed back to Earth. "There is orange soil." This wasn't just any geological curiosity. The orange material turned out to be tiny glass beads formed by volcanic fire fountains billions of years ago, evidence of the moon's volcanic past. Apollo 17 set records that still stand today. Cernan and Schmitt spent 22 hours and 4 minutes walking on the moon across 3 excursions, the longest time anyone has ever spent on the lunar surface. They drove their rover 35.9 kilometers, the longest distance ever traveled on the moon. They collected 110.5 kilograms of samples, the largest haul from any Apollo mission. And their mission lasted 12 days and 14 hours from launch to splashdown, the longest of all the Apollo flights. On December 14, 1972, Gene Cernan climbed back up the ladder into the lunar module for the last time. Before entering, he paused and spoke what he believed might be farewell words to the moon. "We leave as we came, and, God willing, as we shall return, with peace and hope for all mankind." He then became the last person to this date to walk on the moon. As the lunar module lifted off, its ascent captured by the rover's remote control camera, an era came to a close. 12 people had walked on the moon between 1969 and 1972, all of them American men, all of them part of the Apollo program. The Apollo program ended not because we had learned all there was to learn, but because priorities changed, budgets tightened, and public interest waned. 3 missions, Apollo 18, 19, and 20, were canceled, their Saturn V rockets repurposed or sent to museums. The final Saturn V launch came in May 1973, but it didn't carry astronauts to the moon. Instead, it lifted Skylab, America's first space station, into Earth orbit, marking the beginning of a new chapter in space exploration, one focused not on distant destinations, but on learning to live and work in space itself. Skylab was converted from the 3rd stage of the Saturn V rocket, and it was enormous by the standards of the time. Its interior offered 12,700 cubic feet of living space, more room than any previous spacecraft. 3 crews visited Skylab between 1973 and 1974, with the final mission lasting 84 days, nearly 3 months in space, far longer than any Apollo mission. The astronauts conducted experiments in biology, medicine, and solar physics, taking thousands of photographs of the sun and proving that humans could live in space for extended periods without serious health effects. But Skylab's orbit was slowly decaying, and with no space shuttle yet available to boost it to a higher orbit or bring it down safely, NASA could only watch as the massive station fell back toward Earth. On July 11, 1979, Skylab made an uncontrolled re-entry, breaking apart over the Indian Ocean and scattering debris across a remote region of Western Australia. Fortunately, no one was hurt, and some Australians even collected pieces of the fallen space station, with one town playfully issuing NASA a fine for littering. Rest now, and let your mind wander through these achievements. See the rovers bouncing across gray lunar plains, the orange soil glinting in the sunlight, the blue earth hanging in the black sky above. Feel yourself becoming weightless, drifting through the memories of these explorers who pushed the boundaries of what was possible. Part 5. A New Era of Cooperation. Let your thoughts drift now through the years following the moon landings, when the nature of space exploration began to change, becoming less about competition and more about cooperation, less about reaching distant destinations and more about understanding how to truly live beyond Earth. In the mid-1970s, something remarkable happened, something that would have seemed impossible just a decade earlier during the height of the Cold War. The United States and the Soviet Union, rivals in the space race, decided to work together. The result was the Apollo-Soyuz test project, a joint mission that launched in July 1975. An American Apollo spacecraft and a Soviet Soyuz spacecraft lifted off from their respective countries and rendezvoused in orbit, docking together 140 miles above the Earth. When the hatches opened and American astronaut Thomas Stafford shook hands with Soviet cosmonaut Alexei Leonov, the same Leonov who performed the first spacewalk a decade earlier, it symbolized a thaw in the Cold War and a new spirit of international cooperation in space. While the Americans have been focused on the moon, the Soviets have been developing their own expertise, particularly in long-duration spaceflight and space stations. In 1971, they launched Salyut-1, the world's first space station, a cylindrical laboratory orbiting Earth where cosmonauts could live and work for extended periods. Though the first crew tragically died during re-entry due to a valve failure, subsequent missions to Salyut stations proved increasingly successful, with cosmonauts spending weeks and then months in orbit, learning how the human body adapted to prolonged weightlessness. The lessons learned from these early space stations were invaluable. Scientists discovered that without gravity, astronauts' bones lost density, their muscles atrophied, and their cardiovascular systems adapted in unexpected ways. But they also learned that with proper exercise and diet, these effects could be managed. Cosmonauts aboard the Salyut stations followed strict exercise regimens, and their missions grew longer and longer, pushing the boundaries of human endurance in space. As the 1970s gave way to the 1980s, a new vehicle was about to transform space exploration. After nearly a decade of development, NASA's Space Shuttle program was ready. Unlike the Apollo capsules that could only be used once, the Space Shuttle was designed to be reusable, a spacecraft that could launch like a rocket maneuver in orbit like a spacecraft, and land like an airplane. On April 12, 1981, exactly 20 years after Yuri Gagarin's historic flight, Space Shuttle Columbia launched on its maiden voyage with astronauts John Young and Robert Crippen aboard. The mission lasted 2 days, 6 hours, and 20 minutes, testing all the shuttle systems and proving that this new approach to spaceflight could work. The Space Shuttle opened up new possibilities. Its large cargo bay could carry satellites, space station components, and even entire laboratories into orbit. It could deploy satellites and, equally importantly, retrieve them for repair. The shuttle had a robotic arm, the Canadarm, that was 15 meters long and could manipulate objects in space with precision. Over the next 3 decades, the shuttle would fly 135 missions, deploying satellites, conducting scientific experiments, and building the International Space Station. But space exploration was not without its tragedies. On January 28, 1986, the Space Shuttle Challenger lifted off on its 10th mission, carrying 7 crew members, including Krista McAuliffe, a teacher who was to be the first civilian in space as part of NASA's Teacher in Space program. Just 73 seconds after launch, an altitude of 46,000 feet, Challenger broke apart due to a failure in one of its solid rocket boosters. All 7 crew members perished. The nation mourned, and the shuttle program was grounded for nearly 3 years while NASA investigated the accident and made critical safety improvements. It was a sobering reminder that space exploration, despite all our advances, remained dangerous. Meanwhile, the Soviet Union was achieving remarkable milestones in long-duration spaceflight. In 1986, they launched Mir, a space station that would become humanity's first continuously inhabited outpost in space. The name Mir means both peace and world in Russian, and it was designed as a modular station. Different modules could be added over time, expanding its capabilities. Mir was occupied almost continuously for nearly a decade, with cosmonauts and eventually international astronauts conducting thousands of experiments in biology, physics, and material science. On December 21, 1987, cosmonaut Yuri Romanenko returned to Earth after spending 326 days aboard Mir, nearly 11 months in space, setting a new record for the longest single spaceflight at that time. Then, in 1994 to 1995, cosmonaut Valery Polyakov spent an astonishing 437 consecutive days aboard Mir, a record that still stands for the longest continuous time spent in space by any human. Polyakov's mission proved that humans could endure more than a year in weightlessness, crucial knowledge for any future missions to Mars, which will require round-trip journeys lasting years. The late 1980s and 1990s saw increasing cooperation between nations. As the Cold War ended, former rivals began working together. In 1995, Space Shuttle Atlantis docked with Mir, marking the first time an American shuttle had docked with Russian space station. This was the beginning of the Shuttle Mir program, during which American astronauts lived aboard Mir for extended periods, learning from Soviet experience in long-duration spaceflight and building the trust and cooperation that would be essential for the next great project in space. Close your eyes and imagine floating aboard Mir, looking out through its windows at Earth, turning slowly below, the blue oceans, the white clouds, the thin line of atmosphere glowing at the edge of the world. Feel yourself becoming lighter, more peaceful, as weightless as those astronauts drifting to their orbital home, where borders disappear and nations become one. Part 6. Eyes on the Cosmos. Breathe slowly and deeply as we turn our gaze outward, beyond Earth's orbit, beyond the moon, to the remarkable machines humanity has sent into the depths of space to explore worlds we cannot yet visit ourselves. Even as astronauts were learning to live in orbit, robotic explorers were venturing farther into the solar system than any human could go. In 1977, NASA launched 2 spacecraft, Voyager 1 and Voyager 2, on a grand tour of the outer planets. These twin probes took advantage of a rare alignment of Jupiter, Saturn, Uranus, and Neptune that occurs only once every 176 years, using the gravity of each planet to sling them onward to the next. Voyager 2 became the only spacecraft to visit all four of these giant worlds, sending back the first close-up images of Uranus in 1986 and Neptune in 1989, revealing strange moons, intricate ring systems, and storms larger than Earth itself. But perhaps the most profound moment came on February 14, 1990, when Voyager 1, having completed its planetary encounters and now 6 billion kilometers from the Sun, turned its camera back toward home at the request of astronomer Carl Sagan. From that vast distance, Earth appeared as a tiny point of light, barely a pixel in size, suspended in a beam of scattered sunlight. Sagan called it the pale blue, and the image became a humbling reminder of our place in the cosmos. Everything we've ever known, every person who has ever lived, exists on that small, fragile world floating in the immensity of space. Closer to home, another revolution was taking place. On April 24, 1990, the Space Shuttle Discovery launched, carrying perhaps the most important scientific instrument ever placed in orbit, the Hubble Space Telescope. Named after astronomer Edwin Hubble, this telescope was designed to observe the universe from above Earth's atmosphere, which distorts and blurs light from distant stars and galaxies. Hubble's primary mirror was 2.4 meters in diameter, and once in orbit, it could see farther and more clearly than any ground-based telescope. But there was a problem. Shortly after Hubble began operating, scientists discovered that its primary mirror had been ground to the wrong shape, off by just 2.2 microns, about 1/50 the width of human hair, but enough to blur its images significantly. This tiny error threatened to turn the most expensive scientific instrument ever built into an embarrassing failure. However, NASA engineered an ingenious solution, a servicing mission in which astronauts would install corrective optics, essentially giving Hubble a pair of glasses. In December 1993, Space Shuttle Endeavour carried a crew to Hubble for one of the most challenging repair missions ever attempted in space, involving 5 spacewalks over 10 days. The mission was a complete success, and Hubble began sending back images of breathtaking clarity. The images Hubble returned transformed our understanding of the universe. In 1995, astronomers pointed the telescope at what appeared to be an empty patch of sky no bigger than a grain of sand held at arm's length and left the shutter open for 10 days. The resulting image, called the Hubble Deep Field, revealed not emptiness but thousands of galaxies, each containing billions of stars, some of them so distant that their light had traveled for more than 12 billion years to reach us. We were seeing these galaxies as they appeared when the universe was young, looking back through time itself. While Hubble peered into deep space, other missions were exploring our own cosmic neighborhood. In 1997, NASA's Mars Pathfinder landed on the Red Planet, carrying Sojourner, a small rover about the size of a microwave oven that became the first wheeled vehicle to explore another planet. Sojourner traveled just 100 meters during its 83 days of operation, but it proved that rovers could work on Mars, paving the way for larger and more capable missions. The images it sent back, of rust-colored rocks, pink skies, and ancient flood channels, captivated the public and rekindled interest in Mars exploration. As the century drew to a close, construction began on humanity's most ambitious space project yet, the International Space Station. On November 20th, 1998, a Russian Proton rocket launched Zarya, the first module of the ISS, into orbit. 2 weeks later, Space Shuttle Endeavour brought up the Unity module and connected it to Zarya, beginning an assembly process that would take more than a decade and involve space agencies from the United States, Russia, Europe, Japan, and Canada. The ISS was designed as a symbol of international cooperation and as a laboratory for scientific research in the unique environment of microgravity. The first permanent crew arrived at the International Space Station on November 2nd, 2000. American astronaut Bill Shepard and Russian cosmonauts Yuri Gagarin and Sergei Krikalev. They launched aboard a Soyuz spacecraft from Kazakhstan and docked with the ISS, beginning what has now become more than 2 decades of continuous human presence in space. Since that day, there has always been at least one human living in orbit above Earth, making us a truly spacefaring species with a permanent foothold beyond our home planet. Let your mind drift now through the darkness between stars, following Voyager as it sails through interstellar space, or floating peacefully aboard the International Space Station as it circles Earth every 90 minutes. Feel yourself becoming part of this grand story of exploration, weightless and calm, as peaceful as the silence of space itself. Part 7. Tragedy, Triumph, and New Horizons. Let yourself sink deeper into relaxation as we continue through the early years of the new millennium, a time of both heartbreak and remarkable achievement in humanity's journey beyond Earth. The International Space Station grew steadily through the early 2000s, with shuttles and Russian rockets delivering new modules, solar panels, and equipment. But on February 1st, 2003, tragedy struck once again. Space Shuttle Columbia, the oldest shuttle in NASA's fleet, and the same one that had flown the program's first mission in 1981, was returning from a 16-day scientific mission. During re-entry, an altitude of about 200,000 feet over Texas, the shuttle broke apart, killing all 7 crew members aboard. The cause was traced to a piece of foam insulation that had broken off the external fuel tank during launch and struck Columbia's left wing, creating a hole in the heat-resistant tiles. During the intense heat of re-entry, where temperatures can reach 1,650 degrees Celsius, hot gases entered through this breach and destroyed the wing structure from within. The loss of Columbia and her crew was devastating, and the shuttle fleet was grounded for more than 2 years. When the shuttles returned to flight in 2005, their missions focused primarily on completing the International Space Station. The station continued to grow, and by 2011, when it was finally completed, the ISS had become the largest human-made structure in space. It measures 109 meters from end to end, about the length of an American football field, and has a mass of approximately 420,000 kilograms. Its solar arrays stretch out like wings, covering an area larger than a basketball court and generating enough electricity to power more than 40 homes on Earth. The ISS orbits Earth at an altitude of approximately 400 kilometers, traveling at a speed of 28,000 kilometers per hour, which means it completes one orbit roughly every 90 minutes. Astronauts aboard the station experience 16 sunrises and sunsets every day, watching Earth roll by beneath them, deserts, oceans, cities glowing at night, hurricanes swirling over the sea, the aurora dancing near the poles. On July 21st, 2011, Space Shuttle Atlantis landed at Kennedy Space Center in Florida, completing the final mission of NASA's Space Shuttle program. Over 30 years, the 5 shuttles, Columbia, Challenger, Discovery, Atlantis, and Endeavour, had flown 135 missions, spending a combined total of 1,322 days in space. They had carried 355 different people into orbit, deployed satellites, repaired Hubble, and built the International Space Station. But the program had also cost the lives of 14 astronauts in the Challenger and Columbia disasters. As Atlantis rolled to a stop, an era ended, and America temporarily lost the ability to launch its own astronauts to space. For the next several years, NASA astronauts traveled to the ISS aboard Russian Soyuz spacecraft, launching from the same pad in Kazakhstan where Yuri Gagarin had begun his historic journey half a century earlier. Each Soyuz ticket cost NASA about $80 million per seat, and the United States found itself dependent on its former rival for access to space, an ironic twist in the story of the space race. But while NASA's shuttle program ended, robotic exploration flourished. In August 2012, A rover the size of a small car named Curiosity landed on Mars after a harrowing descent that NASA engineers called 7 minutes of terror. The landing system was unlike anything attempted before. After entering the atmosphere protected by a heat shield, Curiosity deployed a massive parachute, then fired rockets to slow its descent, and finally, in the mission's most audacious moment, a sky crane lowered the rover gently to the surface on cables before flying away to crash a safe distance away. The entire sequence was automated, with radio signals taking 14 minutes to travel between Earth and Mars, making real-time control impossible. Curiosity was a mobile laboratory, equipped with 17 cameras and instruments for analyzing rocks and soil. Its primary mission was to determine whether Mars had ever been capable of supporting microbial life. Within its first year, Curiosity found evidence that ancient Mars had indeed been habitable. It discovered clay minerals that only form in neutral water, ancient stream beds, and chemical ingredients necessary for life. The rover found that billions of years ago, Mars had lakes, rivers, and conditions that could have supported life, though whether life actually arose there remains unknown. Far from Mars, another historic mission was approaching its destination. New Horizons, a spacecraft about the size of a grand piano, had launched in 2006 on a 9.5-year journey to Pluto. On July 14, 2015, it flew past the distant dwarf planet at a distance of just 12,500 kilometers, traveling at 50,000 kilometers per hour, so fast that it couldn't slow down or enter orbit, but could only steal a quick look as it raced past. The images it sent back astonished scientists. Pluto wasn't the dead, cratered world they'd expected, but a geologically active place with nitrogen ice glaciers, water ice mountains rising 3,500 meters high, and a vast heart-shaped plain of frozen nitrogen that appeared to be less than 100 million years old, recent by geological standards. Back on Earth, a new era of spaceflight was emerging. Private companies were beginning to play significant roles in space exploration. On May 22, 2012, SpaceX, a company founded by entrepreneur Elon Musk, launched its Dragon capsule to the International Space Station aboard a Falcon 9 rocket, becoming the first private company to send a spacecraft to the ISS. This marked the beginning of commercial cargo delivery to the station, with SpaceX and later other companies transporting supplies, experiments, and equipment to the orbiting laboratory. Rest your mind now and imagine that view from the ISS. The curve of Earth's horizon, the blackness of space above, the station's modules stretching out around you like a metallic tree growing in the void. Feel yourself floating there, peaceful and serene, weightless in the eternal dance of orbital mechanics. Part 8. Return to flight and distant worlds. Let your breathing become even slower and more peaceful as we journey through the most recent chapter of space exploration, a time when humanity began to dream once more returning to the moon and reaching Mars. The year 2020 marked a turning point in human spaceflight. On May 30th, after nearly a decade of relying on Russian rockets, American astronauts once again launched from American soil. SpaceX's Crew Dragon spacecraft, carrying NASA astronauts Doug Hurley and Bob Behnken, lifted off atop a Falcon 9 rocket from the same historic launch pad 39A at Kennedy Space Center that had sent Apollo astronauts to the moon. The mission was called Demo 2, and it successfully demonstrated that private companies could safely transport astronauts to the International Space Station. The capsule's sleek, modern interior, with touchscreen controls instead of the hundreds of switches and buttons of earlier spacecraft, represented a new generation of space vehicles. Following the success, SpaceX began regular crew rotation missions to the ISS, joined later by Boeing Starliner spacecraft. But perhaps even more revolutionary was SpaceX's development of reusable rockets. The Falcon 9's first stage, the largest and most expensive part of the rocket, could return to Earth after launch, landing vertically either on a drone ship at sea or back at the launch site. By 2024, SpaceX had successfully landed and reused first-stage boosters more than 200 times, dramatically reducing the cost of access to space. Some boosters have flown more than 15 missions each, something that would have seemed like science fiction just a decade earlier. While new spacecraft were launching humans to orbit, robotic explorers continue to push farther into the solar system. On February 18, 2021, NASA's Perseverance rover landed on Mars in Jezero Crater, an ancient lakebed that scientists believe might preserve signs of past microbial life. Perseverance was even larger and more capable than Curiosity, weighing 1,025 kilograms, about the weight of a small car. But the rover brought something entirely new, a small helicopter named Ingenuity. On April 19, 2021, Ingenuity made history by becoming the first aircraft to achieve powered, controlled flight on another planet. In Mars's thin atmosphere, just 1% the density of Earth's. Achieving lift required spinning its twin rotors at 2,400 revolutions per minute, far faster than any helicopter on Earth. That first flight lasted only 39.1 seconds and reached an altitude of 3 meters, but it was a Wright brothers moment for another world. Ingenuity would go on to fly more than 70 times over nearly 3 years, scouting paths for Perseverance and proving that aerial exploration of Mars was possible. Perseverance itself carried sophisticated instruments for studying Mars's geology and searching for signs of ancient life. The rover also began an ambitious sample collection campaign, drilling into promising rocks and sealing small core samples in tubes. These tubes were then carefully deposited at designated locations on Mars's surface. The plan is for a future mission to collect these samples and bring them back to Earth, humanity's first sample return from Mars, where they could be analyzed with instruments too large and complex to send to another planet. Beyond Mars, other missions were revealing the wonders of the outer solar system. The Juno spacecraft, which arrived at Jupiter in 2016, continued to orbit the giant planet, flying close to its cloud tops and peering beneath them with its instruments. Juno discovered that Jupiter's Great Red Spot, a storm larger than Earth that has raged for at least 350 years, extends as deep as 350 kilometers into the planet's atmosphere. The spacecraft also revealed that Jupiter's magnetic field is even stronger and more irregular than expected, and captured stunning images of the planet's swirling storms and intricate atmospheric patterns. Even more intriguing were the discoveries about Jupiter's moons. Europa, one of Jupiter's 4 large Galilean moons, has long been suspected of harboring a liquid water ocean beneath its icy surface. In 2024, NASA launched a Europa Clipper mission, a spacecraft designed to make nearly 50 close flybys of Europa to study its ice shell and the ocean beneath. Scientists estimate that Europa's ocean might contain twice as much water as all of Earth's oceans combined. And where there's liquid water, there might be life. Europa Clipper carries instruments to measure the ocean's depth and salinity, to analyze the composition of ice and any materials erupted through cracks in the surface, and to search for signs of geologic activity. Meanwhile, humanity's gaze was also turning back to the moon. NASA's Artemis program, named after Apollo's twin sister in Greek mythology, aims to return humans to the lunar surface for the first time since 1972. On November 16, 2022, the massive Space Launch System rocket, the most powerful rocket NASA has built since the Saturn V, launched the uncrewed Artemis I mission. The Orion spacecraft traveled beyond the moon, reaching a maximum distance of 432,210 kilometers from Earth, farther than any spacecraft designed for humans has ever traveled. After a 25.5-day mission that tested all of Orion's systems, the capsule returned and splashed down safely in the Pacific Ocean. Artemis represents more than just returning to the moon. It aims to establish a sustainable presence there. Plans include building a small space station called Gateway that will orbit the moon, serving as a staging point for lunar landings and deep space missions. The Artemis program also aims to land the first woman and the first person of color on the moon, expanding who gets to be part of humanity's space exploration story. Future missions plan to establish a base camp near the moon's south pole, where permanently shadowed craters may hold billions of tons of water ice that could be used for drinking water, oxygen, and even rocket fuel. Close your eyes now and let yourself float through this new era of exploration. See the sleek spacecraft docking with the space station, the helicopters flying through Martian skies, the rockets landing themselves back on Earth. Feel yourself drifting peacefully through these dreams made real, as weightless as starlight, as calm as the silence between worlds. Part 9. Telescopes, Asteroids, and the Future Beckons. As you drift deeper into peaceful rest, let's explore the latest marvels of space exploration, where humanity's reach extends to the very edges of the observable universe, and our hands touch asteroids billions of kilometers away. On December 25th, 2021, Christmas Day, a remarkable new eye opened on the cosmos. The James Webb Space Telescope, the most powerful space telescope ever built, launched aboard an Ariane 5 rocket from French Guiana. Unlike Hubble, which orbits Earth, Webb traveled to a special location called the Second Lagrange Point, or L2, approximately 1.5 million kilometers from Earth, about 4 times farther than the Moon. At this gravitational balance point between the Sun and Earth, Webb can keep its instruments incredibly cold, which is essential for detecting the faint infrared light from the most distant objects in the universe. Webb's primary mirror is truly massive, 6.5 meters in diameter, nearly 3 times larger than Hubble's, and composed of 18 hexagonal gold-plated beryllium segments that had unfold like origami after launch. The telescope also carries a tennis court-sized sunshield made of 5 layers of special material, each thinner than human hair, that keeps its instruments at a frigid minus 233 degrees Celsius, while the sun-facing side bakes at 85 degrees Celsius. This temperature difference of more than 300 degrees across the structure requires extraordinary engineering precision. In July 2022, Webb released its first images to the world, and they were breathtaking. The telescope captured galaxies so distant that their light had been traveling for more than 13 billion years, showing us the universe as it appeared just a few hundred million years after the Big Bang. Webb could see the chemical composition of exoplanet atmospheres, the birth of stars inside pillars of gas and dust, and galaxies warped and magnified by the gravity of massive galaxy clusters, sights that had been invisible to previous telescopes. While Webb gazed at the distant universe, other missions were reaching out to touch the solar system itself. On September 26, 2022, NASA's DART mission, the Double Asteroid Redirection Test, deliberately crashed a spacecraft into an asteroid called Dimorphos, which orbits a larger asteroid named Didymos. The impact occurred 11 million kilometers from Earth, and the collision successfully changed Dimorphos' orbit around Didymos by 33 minutes, shortening its 11-hour and 55-minute orbital period. This was humanity's first test of planetary defense technology, proving that we could potentially deflect a dangerous asteroid if one were ever discovered on a collision course with Earth. The mission was even more successful than expected. The impact created a debris cloud that stretched thousands of kilometers into space, and follow-up observations showed that the orbital change was much larger than the minimum requirement for mission success. A small Italian spacecraft called LSA-Cube, which had been released by DART before impact, captured images of the collision and the expanding plume of debris, the first images ever taken by a European spacecraft in deep space. Back on Mars, the Perseverance rover continued its exploration, but it wasn't alone. China had arrived. On May 15, 2021, the Zhurong rover successfully landed on Mars, making China only the second country to successfully operate a rover on the Martian surface. Named after the Chinese god of fire, Zhurong weighed 240 kilograms and carried instruments to study Mars's surface composition, magnetic field, and climate. The rover operated for more than a year, traveling over 1,900 meters across the Utopia Planitia region, before entering a planned hibernation during the Martian winter from which it has not yet awakened. China's space program had grown remarkably capable in recent decades. In 2003, China became only the third country to independently launch humans into space when Yang Liwei orbited Earth aboard the Shenzhou 5 spacecraft. Since then, China has built and operated 2 space stations, landed rovers on the Moon and Mars, and returned samples from the Moon. In late 2022, China completed its Tiangong space station, whose name means Heavenly Palace, which orbits Earth at an altitude of approximately 400 kilometers, similar to the ISS, with mass of about 90 tons once fully assembled with all its modules. Meanwhile, the International Space Station continued to serve as humanity's outpost in space, but not without challenges. In 2023, NASA announced that the ISS would continue operating until at least 2030, after which it will be safely deorbited into the Pacific Ocean. The station was originally designed for a 15-year lifespan, but has far exceeded that, with some modules now over 25 years old. The decision to eventually deorbit it came with the recognition that the station's structure and systems are aging, and that future space stations, both government and commercial, would benefit from newer technology and designs. Even as plans were made for the ISS's eventual retirement, records continue to be set aboard it. In September 2023, astronaut Frank Rubio returned to Earth after spending 371 consecutive days in space, setting the record for the longest single spaceflight by an American astronaut. His extended mission wasn't planned. A coolant leak on his Soyuz spacecraft forced NASA and Roscosmos to extend his stay while a replacement spacecraft was prepared. During his year in orbit, Rubio completed approximately 5,936 orbits of Earth and traveled more than 250 million kilometers, roughly the distance from Earth to Mars and back. Let yourself float now through these achievements, drifting past golden mirrors reflecting starlight, past rovers sleeping in the Martian dust, past space stations gracefully wheeling through the darkness. Feel your breathing slow to match the patient rhythm of exploration, where each discovery is a step in a journey that spans generations. Part 10, Private Ventures and Dreams of Tomorrow. Allow yourself to sink into the deepest relaxation now as we explore the newest frontiers of space exploration, where private companies and international partnerships are opening doors that once seemed permanently closed, and where the dreams of reaching Mars grow closer to reality with each passing year. The landscape of spaceflight has transformed dramatically in recent years, with private companies taking on roles once reserved exclusively for governments. On September 15, 2021, SpaceX launched Inspiration 4, the first orbital mission crewed entirely by private citizens with no professional astronaut aboard. The 4 crew members, led by entrepreneur Jared Isaacman, spent 3 days orbiting Earth at an altitude of 585 kilometers, higher than the International Space Station and higher than any crewed mission since the Hubble servicing missions. Their modified Crew Dragon capsule featured a large glass dome in place of the usual docking port, offering unprecedented views of Earth and space. But private spaceflight ventures have pushed even further. In September 2024, SpaceX conducted the Polaris Dawn mission, which achieved the first-ever commercial spacewalk. Mission Commander Jared Isaacman and SpaceX engineer Sarah Gillis both ventured outside their Crew Dragon capsule while it was orbiting at approximately 730 kilometers above Earth, the highest altitude humans have reached since the Apollo moon missions. The entire capsule was depressurized for spacewalk since Crew Dragon doesn't have a traditional airlock, meaning all 4 crew members were exposed to the vacuum of space, protected only by their newly designed spacesuits. During that historic spacewalk, Sarah Gillis became the first woman to perform a commercial spacewalk and, at just 30 years old, reached the highest altitude any woman has ever traveled. The mission tested new spacesuit technology that SpaceX hopes will eventually enable Mars exploration, with improved mobility and a heads-up display built into the helmet visor. The Polaris Dawn crew also traveled through portions of the Van Allen radiation belts, donut-shaped zones of charged particles trapped by Earth's magnetic field, gathering important data about radiation exposure that will be crucial for future deep space missions. While private companies were expanding access to orbit, scientific missions continued to reveal surprises across the solar system. In October 2023, NASA launched the Psyche mission to explore a unique asteroid of the same name located in the main asteroid belt between Mars and Jupiter. What makes Psyche extraordinary is that it appears to be the exposed metallic core of a protoplanet, a building block of planet formation that was stripped of its rocky outer layers by violent collisions billions of years ago. The asteroid is approximately 226 kilometers in diameter and may contain more iron, nickel, and precious metals than all the Earth's known reserves combined. Psyche, the spacecraft, won't arrive until 2029, but when it does, it will provide our first close-up look at a planetary core. Back on the moon, new robotic explorers from multiple nations have been attempting landings. In August 2023, India's Chandrayaan-3 mission successfully landed near the moon's south pole, making India the fourth country to achieve a soft landing on the lunar surface and the first to land in the polar region. The mission's Vikram lander and Pragyan rover operated for 1 lunar day, about 14 Earth days, studying the lunar soil and searching for water ice in the permanently shadowed craters near the pole. These craters, which never see sunlight, maintain temperatures as low as -240 degrees Celsius and may hold billions of tons of water ice deposited by ancient comets. Just months later, in January 2024, Japan's SLIM mission, the smart lander for investigating moon, achieved what is considered the most precise lunar landing ever attempted, touching down within 10 meters of its target location. Previous lunar landers had typically achieved accuracies of a few kilometers at best, but SLIM demonstrated pinpoint landing technology that will be essential for future missions that need to land in specific locations, such as near resources or scientific features of interest. Though SLIM ended up tilted at an angle after landing, preventing its solar panels from generating full power initially, it still managed to conduct scientific observations. The push toward lunar exploration has also sparked commercial interest. Multiple private companies are now developing lunar landers, with NASA purchasing payload delivery services through its Commercial Lunar Payload Services program. In February 2024, Intuitive Machines' Odysseus lander became the first American spacecraft to soft land on the moon since Apollo 17 in 1972, a gap of 52 years, and the first ever commercial spacecraft to land on the lunar surface. Though the lander tipped over on its side during touchdown, it still successfully delivered NASA science instruments and commercial payloads, proving that private companies could reach the moon. Meanwhile, preparations for human missions to Mars continued to advance. SpaceX has been developing its Starship vehicle, a fully reusable spacecraft that stands 120 meters tall when stacked with Super Heavy booster, making it the tallest and most powerful rocket ever built. Starship is designed to carry up to 100 people or 100 tons of cargo to Mars, with the eventual goal of establishing a self-sustaining city on the Red Planet. Through 2024, SpaceX conducted several test flights of Starship, with each flight progressing further than the last, testing the vehicle's ability to launch, survive re-entry, and eventually land for reuse. NASA's own Mars Plan Center on the Artemis architecture, using the moon as a proving ground for Mars technologies. The Gateway space station orbiting the moon will test deep space habitation systems, life support technologies, and solar electric propulsion, all capabilities needed for the multi-year journey to Mars and back. Current plans suggest that humans might reach Mars sometime in the late 2030s or early 2040s, though the exact timeline remains uncertain and dependent on technological development, funding, and international cooperation. Rest peacefully now and let your mind wander through these visions of tomorrow. See the silver starships rising on columns of fire, rovers trundling across rust-red plains, spacecraft gracefully dancing between worlds. Feel yourself becoming part of this unfolding story, floating weightless through dreams of distant horizons, as calm and infinite as space itself.